better than the original virus.
We want to know what mutations are occurring in specific viruses because as now this this clockwork, have more and more mutations that get added to that. And on average, SARS-CoV-2 acquires 1 to 2 mutations per month.
Many of these errors are harmful to the virus, and viruses carrying such mutations will be eliminated.
However, some of these mutations actually are beneficial to the virus. They become the building blocks of selection.
Better fit versions of the virus bind to the host cells and replicate and spread better than the original virus.
We want to know what mutations are occurring in specific viruses because as now this pandemic has gone on for it's caused millions of infections, and there's been so many different opportunities for selection to happen that collectively change the behavior of the virus. So they call those variants.
Why are we seeing rapid emergence of the variants around the world? We don't know exactly what the answer is, but one of the possibilities is that the variants acquired a better ability to enter the host cells and replicate to higher titer than the original strain of the SARS-CoV-2. And when that happens, of course, an individual person infected with the variant is able to replicate more virus and transmit to a larger number of people.
And so what we want to do with the genomic surveillance program is recognize the variants that could be of concern when they're at low frequency in the population, not when everybody's infected with it, because when they're at low frequency in the population, it allows us to react.
In order to protect yourselves from these variants, you will still need to keep wearing masks and avoiding indoor crowding conditions, as well as washing hands, and really getting the vaccines as soon as possible to prevent the spread of these variants. The mutations that concerns scientists right now are the ones that are occurring within the spike domain of the viral genome, because most vaccines use spike as the antigen to immunize a person to develop neutralizing antibodies and T-cell immunity.
What we do know is that there are certain mutations in some of these variants that seem to decrease the effectiveness of really important antibodies.
There is a possibility that the current vaccines may not be as effective in combating these new variants.
But luckily with vaccines, you don't just create one antibody or 2 or 3, you create many different antibodies that recognize all different parts of the virus.
The mRNA vaccine strategy is very flexible and can accommodate new mutations or any kind of sequence that are coming up in the population.
So we have all the tools needed to stop the transmission and the spread of these new variants. We know what works. If we individually and as a community, from our public health leaders on down, really put a lot of effort into all doing our part, these variants won't be able to take a foothold in our community at all.